Okay, in this video I'm going to do an overview of types of solution sets and do one of the practice problems, one type of practice problem, so you know how to do that. Now this section is not so much new material as terminology that explains what we've seen in previous sections. We've seen that you can have no solutions, one solution, or infinitely many solutions. If there's no solution, we call it inconsistent. If there's one or more solutions, we call it consistent. Now, when we've looked at the RAF form, we have seen various properties of the RAF matrix. Some of the rows are zero, some are non-zero. The rows that are non-zero have leading ones. And each leading one corresponds to a pivot column. So these three numbers, number of non-zero rows, number of leading ones, number of pivot columns, these are all the same number, and we call this R. This is called the rank. Okay. We've also seen two types of variables. We've seen that variables can correspond to a pivot column, and these are called dependent or basic. We've also seen variables that do not correspond to a pivot column. We call these independent or free. And we saw in previous videos how to express your solution in terms of the free variables. How do you tell if a matrix is inconsistent? You look at the last column. If it's a pivot column, then it's inconsistent. Now, if the system is consistent, how do you tell if it has infinitely many solutions or not? Well, if all columns except for the last are pivot columns, then there's a unique solution. R is the number of pivot columns, as we saw up here. The rank, what we call the rank, is number of pivot columns, number of leading ones, number of non-zero rows. N is the number of variables. So if R equals N, the system has a unique solution. And if R less than N, the system has infinitely many solutions. So we just have some terminology now to talk about the things that we've been doing before. Now, in this section, we have exercises like this, which may be a little bit daunting. Let me just read the exercise. I'll read it. So it says, determine the value of H such that the matrix is the augmented matrix of a consistent linear system. Now, if it's consistent, that means that the last column cannot be a pivot column. Right? Now, this is an augmented matrix, so you can write it with a bar here to separate the variables from the non-variables, or you can write it without the bar. Just remember that the last column is always the constant column that has no variables, and the columns beforehand correspond to variables. Right? So I'm going to do a problem like this in a notebook. So let me do it here. Okay. So here I want to say find K so that the following system is a consistent system. Okay. And I'm going to give you this matrix. 1, 1, minus 1, 0, 1, minus 2, 1, 0, 3, 0, K, and 1. All right, now, again, this last column is the constant column, and these are the variables column, so I'm just not going to write the vertical bar. Right. Now, what's the strategy here? You want to row reduce and make sure, or I can say, and choose K, so that the last column is not a pivot column. All right, now, so that's a very straightforward strategy. Just row reduce. And then you want to make sure that the last column is not a pivot column. Now, the wrinkle in this is that we have a k here. And we don't really have a way so far of row reducing a matrix that has a variable in it. So let me go down for a second. So one way to do this is just go ahead and do it by hand. Now there are other ways to do it also. You can get Sage to do row operations that have on matrices that have variables, and there are other softwares also. But let me just do this by hand so you can see the idea. And you can try other methods. You should be trying these practice exercises and using different methods so that you're able to perform on the quiz. All right, but if you want to do the row operations by hand, that's fine too. But find a good method, get competent. This is like riding a bicycle. The only way to ride a bicycle is to practice. All right, so let's go with this here. So I'm going to take my matrix again. I'll rewrite it. 1, 1, minus 1, 0, 1, minus 2, 1, 0, 3, 0, k, and 1. Okay. All right, and let's do some row operations. Remember how to do this. I want to put zeros here and zeros here, so this is going to give me R2 minus R1, and then I'm going to have, whoops, sorry, I didn't write it the right way. I usually do minus R1 plus R2 is the way I've been doing it. And then I also want to take minus 3R1 plus R3. So I can do both of those at once because I'm fixing two different rows. So the first row remains the same, 1, 1, minus 1, 0. Then the next one becomes 0. And then this minus 1 plus minus 2 is minus 3. And this becomes 1 plus 1 is 2. And this becomes 0 plus 0 is 0. All right, and then the last one gives me minus 3 plus 3 is 0. Minus 3 plus 0 is minus 3. Minus 3 times minus 1 is 3 plus k. Now see, that's where the k comes in. And then here we have 0. All right, now let's continue with my row operations. I've taken care of the first pivot column. I have 1, 0, 0. Now this is going to be my next pivot column. I'm going to want this to be a 1, and then I'm going to want this to be a 0. All right. So let's go ahead and do that. To make this a 1, I'm going to have to do minus 1/3 times R2, and I have 1, 1, minus 1, 0, 0, 1, minus 2/3, 0. And then the last column I didn't do anything to, minus 3, 3 plus k, and 0. All right, now, to make this a pivot column, I'm going to have to get rid of this one. So that's going to be 3R2 plus R3. And that gives me 1, 1, minus 1, 0, 0, 1, minus 2/3, 0. And then this gives me 0. 3 times R2 plus R3, 3 minus 3 is 0. 3 times this is going to give me minus 2 plus 3 gives me 1 plus k. And then the last row gives me 0. All right, now look at this. Sorry, I made a mistake. Notice that this was a 1 here, and I put a 0 there, so that's my bad. Let's go back and erase it. That's why it helps to do this on software. You can go back and fix your mistakes. Okay, this here, so I got a 1, and here I got a 1, and here I got a 1. All right. Now, look, this last row is in danger of becoming a pivot row. If 1 plus k is not 0, then let's see. If 1 plus k is 0, then this last column is a pivot column. Okay, so I'll just write that. So if 1 plus k is equal to 0, then the last column is a pivot column. And there's no solution. Okay? Now, if 1 plus k is not 0, then this third column will be my pivot column, and I'm okay. So let me write that. So if 1 plus k is not 0, then the last column is not a pivot column. And we can see that by, if I have a number here, if I have a number here that's not 0, then I can divide by that, put a 1 here, and then I can get rid of these and make those 0 and make this 0 and make a row-reduced form. But if 1 plus k is equal to 0, I can't do that. So the condition is, 1 plus k is unequal to 0, or k is unequal to minus 1, gives a consistent system. Okay. So with that information, I think you should be able to do these other problems here. I think you can identify how many free variables. That's pretty straightforward. And identifying when 0 solutions, many solutions, no solutions. Okay, so work through these practice problems. Make sure that you're prepared for the quiz. And that's it.